I've been expecting you.
Mr. Tolentino, I need help with math homework.
Okay.
Welcome to 5-1. It's gonna be fun. The perpendicular bisector theorem is if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. And the converse of the perpendicular bisector theorem is if a point is equidistant from the endpoints of a segment, then it is perpendicular to the bisector of the segment. The perpendicular bisector theorem, we can actually solve for sides. In this example, we'll be solving for yw. So we can see that xw is equal to 7.3, so therefore we know yw is equal to xw, making yw equal 7.3. In this equation, we'll actually be using the converse of a perpendicular bisector theorem. So, from that we know BC is equal to 2 times CD, and BC is equal to 2 times 16, which equals 32, and boom, you have your answer. It's that simple. In this equation, you actually have to solve for both sides in order to find PR. So, using the angle bisector theorem, you're going to put PR is equal to RQ. Using substitution, you get 2n plus 9 is equal to 7n minus 18. Subtract 2n from both sides and you get 9 is equal to 5n minus 18. Add 18 to both sides and you get 27 is equal to 5n. Divide both by 5 and you get 5.4. So PR is equal to 2 times 5.4 plus 9, which gives you 19.8. The angle bisector theorem tells us if a point is on the bisector of an angle, then it is equidistant from the sides of an angle. However, the converse of the angle bisector theorem tells us if the point is on the interior of an angle and it is equidistant from the sides of the angle, then it's on the angle's bisector. With the new given information, we can solve for AB, and AB is equal to DA, and AB is equal to 10. It's also that easy. Now here's where it gets a little more complicated. In order to solve for angle ABD in this equation, you need to equal that to angle CBD. When you substitute everything in, you get 5z plus 23 is equal to 6z plus 14. Simplify and you get z plus 14 is equal to 23. Simplify again, you get z is equal to 9. So you know what z is, and now you put z in, and you get 5 times 9 plus 23, which equals 68 degrees, and you're done with the problem. Here, we're going to use the converse of the angle bisector theorem to find the measure of angle ABD, given that the measure of angle ABC is equal to 112 degrees. Our equation would be angle ABD is half of angle ABC. Substitute everything in, and you should get angle ABD is half of 112 degrees, which equals 56 degrees. In order to write this in a coordinate plane, you need to find the distance of 2 points. First, you gotta graph it, and in this case, it's A and Q. Then you need to find the midpoint of A and Q using the midpoint formula, which gets you 3, -1. Then after that, you have to find the slope of the line, which gets you 3 over 2. But in this case, you need to do the reciprocal of the slope, and that gets you -2 over 3. After that, put it in point-slope form to write your equation, which gets you y plus 1 is equal to -2 over 3 times x minus 3. Congratulations, that concludes 5-1.
5-2. Bisectors of triangles. A perpendicular bisector is a line which cuts a line segment into 2 equal parts at 90 degrees. When 3 or more of these perpendicular bisectors intersect at one point, they are said to be concurrent. The point at which they intersect is called the point of concurrency. If 3 perpendicular bisectors are concurrent, then the point of concurrency is called the circumcenter of the triangle. It is located in the center of a circle that encompasses all 3 vertices of the triangle. Each triangle will always have 3 perpendicular bisectors, and all form one circumcenter. The circumcenter can be located outside of the triangle, on the triangle, or inside of the triangle. Now to practice what you learned in 5-2. Using the information below, find the length of each segment. Okay, if you were paying attention, then you should have quickly figured out that GI was equal to 3, ED was equal to 10, AB was equal to 24, and HD was equal to 16. This was a quite easy practice due to the fact that all of these segments were congruent.
Buckle up your seatbelts, kiddos, because we're about to go on a ride. Destination Chapter 5, Lesson 3. Medians and altitudes of triangles. So, a median of a triangle is a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. This means that the two sides that the median intersects with are congruent. Every triangle has 3 medians, and the medians are congruent. The point of concurrency of the medians of a triangle is the centroid of the triangle. The centroid is always inside the triangle. Don't get it confused with the circumcenter of the triangle, which, as we learned, can be outside or inside the triangle. The centroid is also called the center of gravity because it is the point where a triangle region will balance. So this brings us to our first theorem, the centroid theorem. The theorem is, the centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. That means that in this triangle, AM equals 2/3 of AD, BM equals 2/3 of BE, and CM equals 2/3 of CF. With that knowledge, we can also assume that MD is 1/3 of AD, ME is 1/3 of BE, and MF is 1/3 of CF. Using the centroid theorem, we can find segment lengths in a triangle. In this triangle, triangle LMN, we know that RL equals 21 and SQ equals 4. We have to find LS. Using our theorem, we know that LS equals 2/3 times LR. So we can plug in what we know. RL is 21. Now from here, we can simplify. 2/3 times 21 is 14. So we know that LS equals 14. Now let's do another one. Okay, so we know that SQ equals 4. Now we're going to find NQ. Using our theorem once more, we know that SQ equals 1/3 times NQ. So we're going to plug in what we know. This leaves us with 4 equals 1/3 times NQ. Now we can solve. Multiply the reciprocal of 1/3 on the other side. This leaves us with 12. NQ equals 12. Now let's take a look at altitudes. An altitude of a triangle is a perpendicular segment from a vertex to the line containing the opposite side. Every triangle has 3 altitudes. An altitude can be inside, outside, or on the triangle. In this triangle, triangle QRS, altitude QY is sitting inside the triangle, but RX and SZ are not. Notice that the lines containing the altitudes are concurrent at P. This point of concurrency is the orthocenter of the triangle. Triangle QRS is an obtuse triangle, so the orthocenter lies outside the triangle. In an acute triangle, the orthocenter lies inside the triangle. And in a right triangle, the orthocenter coincides with the vertex of the right angle. Now to solve for the orthocenter ourselves. Okay, so it says find the orthocenter of triangle ABC with vertices A at 0, 0, B at 3, 3, and C at 3, 6. We have 4 steps to solve for the orthocenter. Step 1. Graph the triangle. So here we graph the triangle, with the vertices where they told us to put them. Step 2 is find an altitude. We see that segment CB is straight, so we're going to make the altitude for that one using point C. We see that the orthocenter's y-axis should be at 6, since CB only goes through 6. Step 3. Pick a point. We're going to choose point B purely just because I like that letter. This would also work with point A. We know that the altitude for B should be perpendicular with segment AC. So we have to find the slope of AC and use the opposite of that slope for the slope of our altitude for point B. 0 minus 6 is negative 6, and 0 minus 3 is negative 3. That simplifies to 2. We need the negative reciprocal, which would be negative 1/2. Lastly, step 4, point slope form. We have to put everything we got into point slope form. Point slope form is y minus y1 equals m open parentheses x minus x1 close parentheses. We plug in what we know, y equals 6 and the coordinates of point B. Then we solve. X equals negative 3. So now we know that the coordinates of our orthocenter is -3, 6. So in conclusion, there are 4 steps in finding the orthocenter. Step 1, graph the triangle. Step 2, find an altitude. Step 3, pick a point. And lastly, step 4, point slope form. And there you have it, chapter 5, lesson 3, destination.
So in lesson 4 of chapter 5, we will be learning about the triangle midsegment theorem. The triangle midsegment theorem is when the midsegment of a triangle is parallel to another side of the triangle, and its length is half of the length of that side. So in this problem, we will be examining midsegments in the coordinate plane. The vertices of triangle ABC are -6, 11, 6, -3, and -2, 5. D is the midpoint of AC, and E will be the midpoint for AB. We are going to show that lines DE and CB are parallel, and that DE is half of CB. So first, we are going to be finding the midpoints of lines AC, which is D, and AB, which is E. D comes out to -4, 3, and E comes out to 0, 4. Second, we will be finding the slopes of DE and CB, which both come out to 1/4, and proves that lines DE and CB are both parallel to each other. Lastly, we will be comparing the lengths of DE and CB using the distance formula. DE comes out to radical 17, and CB comes out to radical 68. And since radical 17 is equal to radical 68 over 2, D is therefore half of CB. And that radical 116 is supposed to be a radical 68. I'm sorry, I wrote the wrong number. In this lesson, we will also be finding the side lengths of triangles using the triangle midsegment theorem. In order to find the length of NM, we will be dividing the length of the line XY by 2 because NM is half of XY, and 10.2 divided by 2 is 5.1. We're going to be solving for the angle measure of XLM. We know that LM is congruent to XZ, and we will be using the equation angle ZXL plus angle XLM equals 180 degrees. Angle ZXL is congruent to angle YXZ, which is 29 degrees, and 180 minus 29 equals 151 degrees, which is the angle measure of XLM.
So we're going to start off with our first theorem. This tells us that if two sides of a triangle are not congruent, then the larger angle is opposite the larger side. Looking at the figure, it tells us that segment AB is greater than segment BC, which tells us that angle C is greater than angle A. The second theorem tells us if two angles of a triangle are not congruent, then the longer side is opposite the larger angle, which in this graph, it shows us that angle C is greater than angle B. And that finally tells us our answer, which is segment AB is greater than segment AC. Using the new given information, we can actually rank the angles and sides of a triangle from largest to smallest. So, in this first figure, segment AB is equal to 12, BC 13, and angle AC 10. So largest would be angle A, smallest would be angle B, and the middle would be angle C. Sides of an angle, you need to look at the opposite angle of the side. So, we see that angle C is 30 degrees, angle A is 60, and angle B is 90. So you look at the opposite, and smallest to largest, it's segment BA, segment CB, and segment AC. The theorem of this section tells us that the sum of any two lengths of a triangle is greater than the third side length. So you take the two smallest lengths, and they have to be greater than the third side. So in this figure, AB plus BC should be greater than AC. So you substitute everything in, and 6 plus 3 is greater than 7, and 9 is greater than 7. Yep, that checks out. Final lesson asks us to find the length of a triangle when the lengths are 3 centimeters and 5 centimeters. So the equation we would use is S plus S is greater than S. So you substitute everything in, and you should get S plus 5 is greater than 3, S plus 3 is greater than 5, and 5 plus 3 is greater than S. So you simplify, and you should get s is greater than -2, s is greater than 2, and 8 is greater than s. So you're going to simplify everything, and it should get 8 is greater than s, which is greater than 2. You did it! You finished 5-5.
6. Inequalities in two triangles. This section is essentially about comparing angles and line segments using inequalities. For example, if angle A is 64 degrees and angle B is 75 degrees, then angle B is greater than angle A. This is essentially what this section is all about. There isn't really much to it. However, if you do have trouble, use these two theorems, the hinge theorem and the converse of the hinge theorem. The hinge theorem states, if two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, then the longer third side is across from the larger third angle. Its converse states that if two sides of one triangle are congruent to two sides of another triangle, and the third sides are not congruent, then the larger included angle is across from the larger third side. Essentially, that's it. This section is quite easy and shouldn't give you much trouble. Now to practice what you learned in 5-6. Write an inequality representing the measures of the angles. For example, angle B is greater than angle K. Alright, if you were paying attention, you should have known that angle M is greater than angle C. Angle Y is less than angle A. Angle L is greater than angle Z. Angle Z is greater than angle B. And angle X is greater than angle Y.
Who's ready for another road trip? I am. Put those seatbelts on and get ready, because this time we're going to a very popular tourist spot that I'm sure all of you have heard of. Chapter 5, Lesson 7, the Pythagorean Theorem. The Pythagorean Theorem says in right triangles that the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Just to clarify, in right triangles only. The algebraic way of putting those words is a squared plus b squared equals c squared. We can use the Pythagorean theorem to solve for a missing side length of a right triangle. In this right triangle, we know that the two legs a and b are 6 and 4, and our hypotenuse is x. We plug in what we have, leaving us with 6 squared plus 4 squared equals x squared. Simplify and we get 52 equals x squared. We have to get rid of the exponents on the x though. So finally, we have radical 52, which finally simplifies to 2 radical 13. As DJ Khaled always says, another one. Let's do one more. This right triangle has 5 and x minus 1 for its leg measurements, or a and b. For c, the hypotenuse, we have x. We plug this into our formula and get 5 squared plus x minus 1 squared equals x squared. Multiply and combine like terms. Then we get negative 2x plus 26 equals 0. Finally, simplify some more and we get x equals 13. Okay, so we have something called a Pythagorean triple, which is a set of 3 non-zero whole numbers a, b, and c, such that a squared plus b squared equals c squared. Some common Pythagorean triples are 3, 4, and 5, 5, 12, and 13, 8, 15, and 17, and 7, 24, and 25. We can test these triples out using this right triangle with c equaling 15 and one of the legs equaling 12. Plug that into ye old formula and simplify. Finally, we get b equals 9. All three numbers are whole. In this right triangle, we have two leg lengths of 9 and 12 form a Pythagorean Once more,
triple with
we plug
15.
these numbers into the formula. Simplify. Oh no! C equals 3 radical 34. That isn't a whole number. Darn.
Alright,
9 and
listen, I
15
can
don't
hear
form a
you. Are
Pythagorean
you there
triple.
yet? Are we there yet? Stop your complaining, okay? Because we're almost there. We're almost done, I swear.
We got 2 more theorems. So, the first theorem is the converse of the Pythagorean theorem. It states that if the sum of the squares of the lengths of two sides of a triangle is equal to the third side, then the triangle is a right triangle. The second theorem is the Pythagorean inequalities theorem. It says that if the sum of the squares of the lengths of two sides of a triangle is less than the third side, then the triangle is an obtuse triangle. If the sum of the squares of the lengths of two sides of a triangle is greater
Let's test
than
out
the
these
third side,
theorems.
then
Here
the
we have
triangle is an
three
acute
sided
triangle.
lengths of a triangle.
8, 11, and 13. plugging these into our formula, we get 13 squared maybe equals 8 squared plus 11 squared. Simplify, then we get 169 maybe equals 64 plus 121. Finally, we get 169 and 185. 169 is less than 185, meaning that the triangle is a cube. One more and we're done, okay? So we have side lengths 8, 15, and 17. Plug them into our formula. 17 squared maybe equals 8 squared plus 15 squared. Simplify, 289 maybe equals 64 plus 225. Simplify once more and we get 289 equals 289, meaning that this triangle is a right triangle. Woohoo! And like that, we have reached our destination on the right. The Pythagorean Theorem, Chapter 5, Lesson 7. Thanks for joining us for the ride.
In Lesson 8, we will be learning how to find the side lengths of special right triangles. We also learned 2 new theorems. In the 45 to 90 degree triangle theorem, both legs are congruent and the length of the hypotenuse is the length of a leg times radical 2. In the 30 to 60 to 90 degree triangle theorem, the length of a hypotenuse is 2 times the length of the shorter leg, and the length of the longer leg is the length of the shorter leg times radical 3. By the triangle sum theorem, the measure of the third angle is 45 degrees. So this triangle is a 45 to 90 degree with the leg length of 3. So your answer should come out to 3 radical 2. This triangle is an isosceles right triangle with the hypotenuse length of 7. So to solve for x, you would do 7 equals x times radical 2 and get x by itself by dividing both sides by radical 2. And your answer should come out to 7 radical 2 over 2. When solving for 30 to 60 to 90 degree triangles, you are solving for 2 side lengths, x and y, rather than just x. To find the length of x, you would do the longer leg is equal to the shorter leg times radical 3. In this case, it would be 9 equals x times radical 3. And to isolate the x, you would divide both sides by radical 3, and your final answer should come out to 3 radical 3. Now that we have found our x, we can now solve for y, which is our hypotenuse. We are going to use the equation y equals 2x and use our 3 radical 3 to substitute into the x. And when you multiply that by 2, our y should come out to 6 radical 3. To find x, we would use the equation hypotenuse equals 2 times the shorter leg. In this case, we would do 14 equals 2 times x. And when you solve that, our x equals 7. To solve for y, we would just use the equation longer leg equals shorter leg times radical 3. And we would just need to substitute our 7 into the x. And there's our answer, y equals 7 radical 3. And we have completed everything, yay!